Hi, my name is Zak. I'm a rising junior at Bucknell University studying biomedical engineering, and I'm researching deep brain stimulation of the subthalamic nucleus and its effect on gait disturbances in Parkinson's disease. The subthalamic nucleus, or STN, is the standard target for deep brain stimulation, or DBS, for Parkinson's disease. DBS is a neurosurgical procedure where electrodes are implanted into the brain. Electric stimulation from DBS alleviates many of the motor symptoms associated with Parkinson's disease, including gait disturbances. A generalized stimulation approach may not be optimal for every patient due to the diversity of their symptoms. The goal of my project was to identify the ideal stimulation spot for STN DBS to treat gait disturbances in Parkinson's disease. My project utilized patient-specific imaging data from a retrospective study of 40 Parkinson patients with 72 implantation sites. The volume of tissue activated, or VTA, is a 3D representation of the spread of stimulation in the brain. I quantified the overlap between the VTA and the STN to determine STN activation in the X, Y, and Z directions. The first figure on the left of my poster shows the overlap between the VTA and STN. The figure below shows a split between two halves, anterior and posterior in this case. After calculating STN VTA overlap, I performed linear regression analyses between STN activation and symptom improvement for 4 symptoms: gait, freezing of gait, postural stability, and total gait, a combination of the other 3 symptoms. I then grouped patients based on where the majority of the overlap between the VTA and STN was located, relative to the center of the STN. I used the Kruskal-Wallis test with corrections for multiple comparisons to compare symptom improvement between groups. I completed 2 more analyses following the same process, one taking place in the area of activation outside of the STN to evaluate surrounding structures, and another solely based on the active contact electrode location. Shown in the results section, I found a significant relationship between anterior STN activation and gait disturbances. These results suggest that more anterior STN stimulation may be preferable to posterior STN stimulation for patients whose primary symptoms are gait disturbances. For the external analysis, I found a relationship between anterior external STN stimulation and freezing of gait improvement. This finding suggests that a structure anterior to the STN and external to it may be an optimal stimulation target for freezing of gait specifically. The active contact analysis showed no relationship between active contact position